Participants, kindly switch off your mobiles. Switch off your mics. Sorry.
Sandosh sir, shall I start now?
Yes, sir.
So good evening, one and all present here. So once again, I welcome all the participants for this session. So directly, I hand over the session to Dr. Sandosh Paramashivam. Sir.
Thank you, sir. Once again, a warm good evening to everyone in the FDP. So today we will be seeing about wireless sensor networks. Hope I am audible. So yesterday we did see about a lot of sensors which are being used nowadays with respect to the advancement in AI and lot many other requirements which we have now. So this is literally a continuation of that, because with only sensors, definitely we will not be able to do anything. Of course, we just collect data, but who's going to process it, how we are going to collect it and uh, analyze it, all those things. Then there should be some network be available for us to do all those analysis. So there comes the wireless sensor networks into picture, right? So with that introduction, let me move on. As usual, I work with written, and all these sustainable goals are very, very essential, for which we are moving on to each and every agenda which we are looking into nowadays. And this is the nine important sustainable goals which we should be focusing, and as an individual we will be able to contribute as well. So furthermore, this is what is the flow of the argument is going to be today. So first we will have a general introduction of what is a wireless sensor network, and then we will have the general architecture of the wireless sensor network, then key components of wireless sensor networks and different types of wireless sensor networks we have, and then the potential areas of applications. Again, a short review of all the sensor networks we need or sensors we need. Then we will see about the challenges and future trends in short, and concluding with the conclusion. So this is going to be the flow of today's presentation. And when we see the flow, you may have a question. All the points may be okay, but why do we have a specific topic on types of wireless sensor networks? What is this types is all about? See, with respect to the type of application and the place where we are going to place it, these wireless sensor networks have different requirements. That is what we will be seeing in the types of wireless sensor networks. So with this, let me move into the argument. So first is introduction. Why do we need these wireless sensor networks, or where we need these wireless sensor networks? See, from starting from health to military, it's like all the fields. Today we have many applications starting from our here, as it says health, we will start with health. From health monitoring, of course, we use a lot of smart devices to monitor our health. And then, as we were discussing, when it comes for the context of a smart city, your IoT connected devices, connected cars, smart TVs, smart washing machines, and whatnot. Everything today, what we use have become smart. And why do they have to be smart is the other question. But wherein, when they become smart, which means there requires some external connectivity to analyze the smartness, there comes this sense wireless sensor networks or this wireless networks into picture. So and from in these, here it goes through home automation, environmental monitoring and tracking, and many other human activities. So these are the wide areas where we need these wireless sensor networks. And what resulted here is that, as I was telling little earlier, everything is becoming smart. So because of this expansion that has happened in IoT or IoT enabled devices, there is a huge amount of data. Like as I was telling earlier, when you are getting data, in the sense, say for example, let us consider our smartwatch as a simple example. What are the parameters that our smartwatch measure? Is it one or two or three? Of course, definitely there will be some minimum five parameters that are being monitored by our smartwatch, right? Let it be five parameters, which means five number of data. And how frequent is it monitoring? Is it monitoring once in a day? Like we have a calendar, not daily calendar at home, we just tear off one page per day. Is it happening like that? Or is it some monthly calendar we turn it once in a month, something like that? Or is it like an yearly calendar we change every year? Is it something like that? Does it have such intervals? Does it have a 24-hour, or is it our watch, say for example, which shows time? It just changes for every minute, then every 30 minutes, every 1 hour. The time changes like that, right? From minutes, seconds to minutes, and then minutes to hours, hours to day. That is how the time also changes in our watch. Does this data has some such time frames? Why I even say our watch seconds is that we are now speaking of data collection in micro and nanoseconds. We are very much aware that every single second now, the smartwatch which you wear counts data in every fraction of second, and then it collects data from that. You imagine let us consider your smartwatch is collecting 5 minimal data for every second. So if your smartwatch is collecting one set of data for every 1 second, which means five number of data for 1 second. So your time will be another parameter. So totally you will have six number of data for every single data, which means it has six parameters, six different parameters, right? So every second. So for 1 minute, how many data it is considering? It is collecting 360 for 360 seconds, sorry, 60 seconds. We have 1 minute which collects six data for every second, which becomes 360 data. So again for 1 hour, how much it is? So again for 1 day, how much it is? This is all for one person. Like if we are four people in the house, there are four smartwatches, then you just imagine the amount of data that is being collected, right? So this data is literally a heterogeneous data, and it is collected in an exponential rate. This data is not only of interest of us. We literally don't have any necessity, or we are not as an individual, we are not interested. Okay, my heartbeat was so and so at 742. Now it is 7:45. What is my heartbeat? Are we going to see that like that? No, it's not the case. But when it comes for research, and when it comes for the industry requirements, say for example, when you consider a manufacturing industry, we know that the automation has taken over the complete manufacturing industries. Say in 1 minute, the chocolate manufacturing company is capable of producing thousands and thousands of chocolate in 1 minute. Say a minimum of 1,000 candies can be produced in 1 minute, like, or in 1 hour. Say let us say 1 hour. In 1 hour, it producing thousands of chocolate. So there, this data is very very essential for every minute, how much it is, how the production is going on, whether the production is picking up or it is slowing down or it is maintaining the phase. So when it comes for industry, these kind of data, even though they are heterogeneous, even though they are in exponential rate, industry is very much interested in this data because it is very essential for them to monitor their production. And also when it comes for research, people are very much interested. Why is that? When we say about research, it is not only the industry that comes into picture, wherein your environmental monitoring comes into picture, individual health comes into picture, right? These are two simple example I'm giving you. And you just imagine about the number of cars we use nowadays. And so this goes beyond what we think, because when it comes for a smart city is concerned, there we are concerned about the traffic as well as the pollution and lot many parameters. So this becomes this heterogeneous data and exponential increased data is again exponentially required for the kind purpose of research. And also data collection is one of the important part when it comes for research is concerned. So where the more the data, the more the efficient the systems, as because we are now dealing with everything with AI. So when it comes for AI, their data is wealth. Earlier we used to say information is wealth. Now data is wealth for any AI system to learn and to tune, right, itself. So therefore, these data are very key for industry as well as research is concerned. And then when it comes for, as I was telling you a little earlier, when it comes for this wireless sensor network, the ultimate purpose of these networks is to collect data. Data collection is the only role that these wireless sensor network does. What type of data, where it is collecting, these varies with respect to the application, or where we are going to, what kind of application we are going to use, and where we are going to get the data from. That is the only change that is going to happen. But wherein, apart from that, when we generalize the wireless sensor network, the ultimate work or task of these networks is to collect data. Fine. Furthermore, what does these wireless sensor network do? As I said, the collected data is just transferred. They just collect the data and they just send it to a central location for processing and analysis. So when it comes for central location, there are two divisions in this. One is like we will have a sub point or a local interface where these data goes there for the first iteration. And as I was telling you yesterday, what happens is that the recursive data will sometimes be filtered in the local station and only the essential data. Say, for example, as I was telling you, when you monitor the heart rate of a person, right? So we know that the person's heart rate is same continuously. And when there is a change in the heart rate, say for example, it was like 50 beats. Let us have it as 50, for example, and suddenly it goes to 55, or it less goes down to 45, right? So when such a variation is happening, then there will be reporting will happen. In the same way, all the data, say if you consider the climate monitoring, the temperature is staying at 32 degrees. Okay, at 1 o'clock it is 32 degrees, and again 2 o'clock it is 32 degrees, again it is 3 o'clock it is 32 degrees. Then there is no necessity for sending all the data. Of course, we have to send it is 32 degrees at 1 o'clock, 2 o'clock, and 3 o'clock. Wherein from 1 to 159 it remains the same. So we can skip all the data. If you see most of your weather apps, they just give you a graph stating that from this point to this point, this is the graph. It is generally a graph because they take specific points to mark or to predict your graph. Likewise, the initial filtering sometimes happen in the local station, and only the very essential data goes there. Right? You can also say it as data defragmentation is happening in the local stage, and then only the filtered data is being sent to the central cloud or your server, kind of things are there. So these things, when we see about the components of the wireless sensor network, we will be able to know what are the components, how it is being done, all those things we'll see in the future slide. And one important problem or challenge we have in this is, as I was telling, when I was telling, I hope you can just think of the big picture where the expansion of these wireless sensor network is happening. That is the scaling up. So when this expansion is keep on going, then we have the challenges in network architecture, what kind of network we are going to do, and also data routing, right? Data routing. These two are the important challenge which we have or which we still face in wireless sensor network, right? So this is a brief introduction of what is wireless sensor network, what is the purpose, where we use it, and what are the challenges. Moving forward, the general architecture of wireless sensor networks. So this is just for our understanding. So the total wireless sensor network, we can have it as three levels. The first level is all about sensors, right? And the second level is about data acquisition and process. And the third level is monitoring and control. So here you can have it like, see, you can see when it comes for the sensor is concerned. So we have level sensor, pressure sensor, flow sensor, density, temperature, environment. These are all just indicative purpose. These sensors which has been given here are just indicative purpose. The only reason for giving these sensors is that it has a very unique, each and every sensor has its unique functions. So then we should also think about this, because whenever we speak about sensor network, the first thing that comes into our mind is that, okay, we will have a temperature sensor, we will have a humidity sensor. So these are the basic things that comes into picture. And when it comes for a factory automation or other specific application is concerned, we generalize the sensors there, right? We generally generalize the sensors there. So wherein here it is not the case. Here, all these sensors are not only applicable in industry, but earlier these were main or important sensors which are a part of industry alone. But now, when it comes for a smart home automation, right? When it comes for a smart city application. So when you consider there, these sensors comes to our home. Say, for example, with flow sensor, you can monitor the total amount of flow that is you have for your house. Say, for example, now we have the water meters in all our houses, right? So there we use a flow sensor, right? And for your tank level monitoring, you can go for your level sensor, right? These are all these sensors has already reached our home steps, which we are not really aware of. So we have to consider each and every sensor, because their characteristics are different. Their the data which we get from them, we generalize, right? We just yesterday saw that a sensor is something which measures the physical quantity or biological or chemical and then convert into electrical. So there, when you go for a wireless sensor network, you should consider what type of sensor we are using at the end and what type of data we are having it, because When it comes for the ground level sensors are concerned, the data transferring protocols vary. The second level of wireless communication and things which we are familiar with uses a Wi-Fi, a Bluetooth, or some other RF communication, right? This is what generally we use. But when it comes for the low-level devices, say we call them as the sensors are called as low-level devices. There we have different protocols. We have I2C protocols. We have USART protocol, right? Some different types of protocols are there. So our sensor network, whichever we are going to deploy, should also be capable of understanding what is the sensor we are going to use and what kind of data it is going to give and how we are going to receive it. So these parameters has to be concerned. This is where now the technology is moving forward. Now the industry 4.0 sensors, if you consider, all the sensors are IoT enabled. The earlier it was not the case, but now currently all the sensors are IoT enabled, which means they themselves do all the process. The each and every sensor will have their own processor. Probably you will see that when it comes for the sensor node part is concerned. So let me skip that now. So everything is there in your I 4.0 or Industry 4.0 sensor concerned. When it comes for the Industry 5.0 sensors or I 5.0 sensors, there even we will have an AI component into it, so it just does the decluttering as well and sends only the very essential data to the next level to the data acquisition part and process part. So the next level comes as your data acquisition and process, which means we collect the data from your sensors and either we declutter it there and send only the essential data, or sometimes we just send everything to the other end. So it depends upon the application what we use, it depends upon the place it is being used, and it depends on many such parameters. Finally, after this stage, the third goes to the monitoring and control, where it does not only do the monitoring and control, and also that is the prime area we have the data storage, right? So all the data, say this intermediate part may not have the entire data. Say for example, if you are collecting data for a continuous time period of 1 hour, like sorry, 1 hour or 1 month or 1 day or 1 year, sensors will have the instantaneous values, and the next level will have the data for a short span of time, say for example maybe 1 day, wherein the final stage will have the entire data from day one to the current date. All the data will be stored there as well. So there it is not only does the monitoring of the system, it does not only control the system, also it has the complete data storage is also concerned. Fine. So next is again, when it comes for this particular methodology or way of collecting data, generally, when we speak about an architecture of any communication system, the general architecture, what we know is a 7-layer architecture, right? Wherein, when these wireless sensor networks are concerned, these are basically a 5-layer architecture networks. Here, the total tasks, whatever we do, are classified as a task management plan, then mobility management plane, and the third one is power management plane. There are 3 planes. What are these 3 planes? Is that first is task management plane. What does this task management plane means? That is the sensor part, acquiring data from the real time. That is the first stage, task management. And the second is mobility management. Here, the mobility management means transferring the acquired data through some network protocols to some other point. That is what is meant by mobility management. And the third part is power management. Of course, when you see, we have been speaking about the sensors is there, then the data acquisition units are there, then monitoring unit is there, everything is there. But each and every level or each and every stage, if you see, there is a power requirement. So each and every sensor requires some power to work with. And as we were telling, it is gonna work continuously. So it requires a continuous power all along. And then again, your data acquisition module should also be working continuously, and also the remote monitoring system should also be working continuously. So we will know that even our mobile phones, if you use continuously, it can hold your charge maybe for up to 8 hours or 9 hours or 24 hours. It depends on what you how we use it. So therefore, the concern of the power or the energy that is being used also is an important factor. So all these three main parameters are considered, and then again, and ensured that all these three planes have the same kind of architecture. This is a special, or this is a way how these wireless sensor network architecture is planned. As usual, we have a physical layer, then the data link layer, then the network layer, then the transport and application layer. So these are the five areas or five layers based on which our wireless sensor network protocol is being built on. And this is applicable to all the planes. One is your task management, mobility management, as well as the power management of our wireless sensor network. Then comes the key components of our wireless sensor networks. The first component, so this is an illustration of our wireless sensor network. You can see here we have some sensors. Then we have something called as N, which is called as nodes. Either we can call it as a sensor node or sensor separately and a node separately, and then a gateway, right? So first thing is sensor node. Followed by that, we have a gateway and a base station. Again, this gateway or base station is where we collect or centralize the data that is being collected from one particular sensor group, and then it is being sent to the other part. And then how it is being sent is the communication protocol. Generally, for these wireless sensor networks, we use Zigbee, Wi-Fi, LoRa, that is long range Wi-Fi is called as LoRa, and then we have Bluetooth. These are the few major communication protocols which are being used. Apart from these protocols, there are few other protocols are also being used. In the later part, we will see what is the benefit of each and every protocol, where and why we have to use a particular protocol is concerned. Fine. So here there is one more illustration. So this is the overall picture of our wireless sensor network. So you can see here from the sensor nodes, data is being collected. We have numerous number of sensor nodes there. Then it goes to the base station, and from the base station, it reaches the end user or the server, right? So this is the overall picture of the different components that are there in a wireless sensor network. Now let us dive into each component. First is sensor node. What is a sensor node? What does a sensor node have? Does it have only a sensor? We just, when we speak about a wireless sensor network, so far we have been just saying okay, we will have a sensor, we will have a gateway, and then we will have a centralized data acquisition system, and then after that it goes to the cloud. Okay, fine, all are very simple. Or when it's seen as a whole picture, it seems to be very simple in nature. But now we will see the real complexity of these networks. Why we are concerned about power management as well. Because when you consider a single sensor node, say for example, one sensor, for example, then you can see that we have a minimum of two sensors. Let us consider here. Here I have given two sensors. We have two sensors. From that sensor, the data being first acquired, it is sent to an ADC or whichever type of protocol it could be. It is just a converter. Then that particular data is sent to a microcontroller, and then from there it is given to a transceiver, where from where it goes to the centralized using whatever it is. Then there are four subsystems we have in every sensor node. The first is a sensing subsystem, that is the sensor part. Then it is the computing subsystem, where you will have your microcontroller coming into picture, right? The third part is a communication subsystem. There again, you will need either a Bluetooth or Wi-Fi or Zigbee, some communication protocol you should have in that. Every sensor node I'm speaking about, I'm not talking about the entire picture. Every sensor node, say for example, if you want to collect one data from a one particular area, then that particular sensor node will have all these things. And then you will also have a power supply subsystem. So once again, I'll just quickly move on to the previous slide. So here you can see there is something called as sensors, right? The yellow color circles are there. Na? And also here you can see something as sensor node, small dots. Na? Each of these small dots or each of these yellow circles are the baseline of our wireless sensor network, and in each of them we have all these four subsystems. So we will need a sensing system, that is a sensor, and then from there we need a microcontroller to which the data is being sent from the sensor, and then again from that microcontroller it has to transmit the data. So then again you need some communicating device, which means you will have a Bluetooth antenna or a Zigbee antenna, whatever it could be. And then for all working of all these things, we will need a power supply as well. So in whole, if you see, this is a one small system, there is a small part of the wireless sensor network which will require all these parameters. So now you can really start realizing how complex it is going to be. Why? Because later part when we see the applications, you will see, okay, this many applications are there, this is there, fine. So when you see the application as a whole, it may seem simple, but when it comes for the computational process, when it comes for the data sensing, and when it comes for the transformation, why we speak about the heterogeneous data, and then why we say as exponential data, all these terminologies comes into picture because each and every segment or each and every small dot which we have in our WSN or wireless sensor network as a sensor node has all these subsystems, which makes the complexity of the system, physical complexity I'm meaning by, and also the data collection and everything. Again, everything is a complex. I don't say or I don't deny those complexities, but still the deep care that any individual should, or any company or any particular application when we design, should be taken from the level of this sensor nodes, so that we should always ensure that the data what we collect should be the right type of data. We cannot say the right data, because the right type of data what we get is very very essential. And then how we are going to store these data and how we are gonna transmit this data, all these parameters comes into picture. So this is very very a key point which we or an individual or a designer should have in their mind, right? Right. Then the next part is gateways and base stations. What is this gateways and base stations is that? So here there is an illustration. You can see all the yes, whatever I have given here is the sensor. And you can see something as CH, that is supposed to be your gateways, through which you can see that there are many sensor nodes. From each sensor node, a data is being transferred to the gateway, and from the gateway, it is being transferred to the base station. So I'll just give you one more illustration so that it will be easy for us to understand as well. So here you can see all the red circles which we have given here are the sensor nodes. From these sensor nodes, we are sending data to a particular gateway or a particular location which is called as a gateway, and from that gateway the data is being transferred to the base station, and from the base station again it will be sent to the centralized server or the central monitoring system. As usual, if for like every network topology, here also we can go with the a star topology or mesh topology. It depends on the requirement of the application. Again, why this is being said is that with respect to the topology, the power consumption also varies. Each and every topology has a different power requirement. So, and also each and every communication protocol has a different power requirements. Say your Wi-Fi has a different power requirement, your Bluetooth has a different power requirement, and your Zigbee has a different power requirement. Likewise, every protocol has a different power requirement. So, based on that power requirement, as I said, this is going to be a continuous system. Those topologies and the protocols you are going to use is also very 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 important to consider. So that is why these things plays a crucial role. And followed by this, we have two other models also, how the data is being collected. So I'll just go here. So this is another methodology, or this is an overall what to say, this is another method how we can collect data. So we have a centralized, it doesn't mean that UAV means here you will have a centralized system in between your base station and all your nodes. There you will have collect all the data. This is a multi-tier network. What we see here as a multi-tier network. this, as I was telling earlier, to reduce the power consumption. If you see in this case, here you can see that for every cluster, you will have a centralized node, and from there, every node is being sending to the base station. So here, if you see in this, it is a bit more simplified structure where for a particular system, we have one UAV, and then from there, it is sent to the base station. Base station is being supported by another layer or another intermediate channel through which the number of base stations can be reduced. Furthermore, to this also you have another multi-tier, right? This is another multi-tier protocol where you can see that you, for the data transfer, you have the sensor network first, and then you have two tiers of receptions, or the gateways, we can say in other words, and from there it moves to the other gateway, and then finally from there to the base station. So this reduces the number of intermediate nodes or intermediate stations, so that the number of intermediate stations will reduce. So that is one ultimate purpose of having such kind of intermediate levels. And you can say, so then we can even have one more. Of course, we can even have one more, but again, that depends on your applications. For a simple application, we cannot have too many number of layers, which again will incur an additional cost, right? So that is also another parameter which we have to consider. And then comes the communication protocols. So when it comes to the communication protocols, as I was telling you earlier, you can see that we have a Zigbee, then we have a Z-Wave, then Bluetooth, Wi-Fi, WiMAX, and then Sigfox. So these are some of the common networks. Maybe here Z-Wave, WiMAX, and Sigfox are not common to every individuals, wherein Zigbee, Bluetooth, and Wi-Fi are known to us. And there is also one more, two more protocols. One is your LoRaWAN, which I have not given here. The other one is BLE, Bluetooth Low Energy Network. So these two, Bluetooth Low Energy Network and LoRaWAN, are currently being preferred for most of the applications. Why? Because your Bluetooth low energy network and LoRaWAN, they both similar. They use a similar data transmission protocols, and they consume very less energy. And there is a possibility for us to communicate between your BLE and LoRaWAN. So in such a case, the compatibility of data collection will be easier with that. So that is in the current. That is the current research or current area of focus where researchers are working in. But these are the generalized protocols which are already in the market. And then here, this particular table gives us the details of each and every protocol. You can see what is the maximum data rate, the bits that can be transmitted, what is the maximum payload, what can be the additional payload as well. So to start with, you can see that here Zigbee is gonna be 250 kilobytes per second, and then you can see the Z-Wave is 100 bits kilobits, Bluetooth is 1 megabit, Wi-Fi is 9.66, WiMAX is 1 gigabyte, and then Sigfox is 600 bits per second. So Sigfox is supposed to be the smallest network you can have with a very little data transfer, 600 bits per second, right? So here you cannot just see the numbers, it's just 600 bits per second. And then for 1 microsecond, the maximum number of data that can be transferred in 1 microsecond is 3.9, 9.8. You can just see out the details of what it is. So it is not the purpose of us trying to find, okay, which is the best for me, which can I use. It is not the case, because as I was telling you earlier, even Sigfox will be better for us when we have a less number of data and the requirement is very less. And even in times, maybe Wi-Fi is not enough for us, because that is the only thing which we have the highest, 9.6 gigabits per second. So even that Wi-Fi may not be enough for us in some applications, right? So do we have such an application? Yes, of course we have such application. So with respect to the type of data which we are going to get, and with respect to the application to which we are going to use, these will change, right? Fine, then. So let me move forward. There is one more thing that is with respect to this. Yeah. again, here we have been discussing about, we have been seeing about the different protocols, right, in the gateways and base stations. Again, when it comes for the communications, there are two types of communication. One is one hop communication. You can see that each and every sensor node is connected to one sink, or like it's like a cluster head. You can see that sink is nothing but a cluster head, wherein from there you just get the data, right? So sync is not a cluster head. Either you can have one sensor or one cluster to collect data and send it to one sync. So that is what is called as one hop communication. And when you have it as multi-hop communication, you can see that you will have multiple nodes connected together, forming some kind of internal network, and then from there we send it up. So this is very similar to the aerial networks what we saw earlier, right? This is another two methodologies or two ways in which we can communicate. Then types of wireless networks. So this is what I have been telling you earlier. Like with respect to the place, our application changes. With respect to the application, it changes. Yes, of course. What is the difference between application? What is the respect? What is the difference between your application type and also the other things? Is the question that would have come to you. See, with respect to the place, now you can see the different types of wireless sensor networks. You can see here we have something called as terrestrial wireless network, we have something called as underground wireless network, underwater wireless network, multimedia wireless network, and mobile wireless network. How come these be different? Right? That is one question that we have right now. Because when it comes for wireless sensor networks, or when it comes for a network, we just consider only about the topologies which we use, the data transfer rate, and these are the prime things which we have been concerning all these years. But here we have something new, because why we say something new is that what is the difference between a multimedia network and a mobile network and a terrestrial network, and what is the role of this underground? Where come this underground we are going to use? Okay, even sometimes let me even agree with the underground, but what is this underwater wireless sensor network? Why should I be needing an underwater network? So this would be the question that is popping into our minds right now. So let us have the answers for these questions that is popping into us. So the first one is terrestrial wireless sensor networks. So these terrestrial networks are intended to be deployed in the terrestrial space. What is the terrestrial space? Terrestrial space, we know what it is. It is generally the ground levels. It could be it could be your households or some everywhere, your forest or your mountains, whatever you consider everywhere. It is just this the global arena. We call all the terrestrial spaces. It can be of any place. So in here we place hundreds and thousands of sensors. Either we place it randomly or deterministically. Why we say randomly and deterministically is that, see, like what is the distance that is being traveled by me or for by a particular car, and so on. So what is the speed of a car that is being traveled? So to calculate this, generally what they do is that they place one starting point at a particular point. They will just position some sensing methodology in another position. They will place another sensor. Say for example, two sensors are being placed at two different places. The distance between these two sensors are always the same. So if some vehicle crosses the first and second sensor, then with respect to the time that is taken by that particular object or a car or vehicle, they can easily determine what speed that particular car or vehicle has crossed that particular area. So this will enable us to monitor the traffic rules. This is a simple example I'm giving you. So this is what we call it as deterministically placed. When it comes for randomly placed, we just have to monitor the climate. We just would like to monitor how many cars are passing. We just would like to monitor how many number of people are going, something like that. Some random applications which does not be very deterministic, but it is just that data collection alone is enough. Then the sensors can be placed randomly. Say for example, if a car or if a vehicle is passing through NH47 and there is two deviations, say 174 and 109. This is just an example. So how many number of vehicles that passed NH47 is coming in NH4079 or NH109? So this is something which we have to calculate. If it's the application, then we can randomly place one sensor in NH47, one in 79 and one in 109. So with these, we can easily calculate, okay, this because there is only two deviations. So this is assumed that only there is two deviations. Whichever car or whichever vehicle that comes in 47 has to go either in 79 or in 109. So this is if this is the case, then we can place three random sensors, and then from there we can just collect the data. Right? This is all simple examples for us to understand the positioning of randomly placed and deterministically placed. Then the purpose. Generally, these sensors are used for environmental monitoring and natural phenomena monitoring. That is the first thing. Here, what is a big challenge is that the energy management. That is one big challenge we have in this terrestrial application. Why? Because as it was clearly mentioned, we are going to place hundreds and thousands of sensors. So, we just saw what a sensor node has. A sensor node will automatically have its own microcontroller, it has its own battery or the source, and then it has some data storage device, it has a communication device. So, everything comes into it. So, therefore, when you place numerous number of sensors, it is gonna be energy management is a very big issue when it comes for this kind of network is concerned, right? And then the next comes your underground type of networks. So these kind of sensor networks are generally placed under the ground. That is why this is called as an underground sensor. So how it works is that these sensors that are placed the below the surface of earth transmit the data to a base station, say generally to some place where it is above the ground level. This type of networks generally we use it in agricultures, minefields, right, to monitor the soil conditions, and also the when it comes for minefields, what is a minefield, right? So there you could have some destructions or something may happen. So to ensure that doesn't happen, we are having such kind of sensor networks to monitor the variations that is happening in the under the ground. And of course, you may ask, sir, what's the kind of sensors are we going to? Yes, we have sensors. Seismic sensors are there which can be placed to identify all these things. In many cases, or in the recent cases, to measure all your earthquakes and other things, such kind of sensors are being used. The main drawback or problem with these kind of sensors is that from this application, it is very clear for us. These sensors should be very very critical and crucial. So they should have a higher production. They should be made up of high quality material. So when it comes for such things, these generally are called as special sensor nodes. Because of these characteristics, it is called as special sensor. And underground implementation, placing them and maintaining the sensors is very very costly. So when it comes for this particular application, here the ultimate concern is about the cost of their implementation and maintenance. If the above case it was energy management, in this case it is not energy management, because here the sensors are number of sensors are going to be less, but wherein the cost involved for the manufacturing of those sensors, then implementing them underground and then maintaining is the highest concern we have here. The next part is going to be your underwater sensor. So now, what is the purpose of underwater sensor? Now we have a lot of data that is being transmitted under the water. First of all our internet lines and all these things are coming under it. And moreover, the pollution that is happening in the sea or oceanic region causes a very drastic effect on the people which people live in the land. So now that nowadays the frequency of your floods and all other things are it is all undeterministic, right? Because all these changes are happening because of the change in oceanic life and oceanic climate. So the earth, we are very much aware that the three one third of the earth is only land, the remaining is all water, right? So those areas, the disturbances that is happening there gives a very ill effect to the people living on the land. So oceanic monitoring or marine monitoring has become a very important requirement in these days. So that is why we are in need of this underwater sensor network. And again, here the hostility of the environment of their deployment makes this type of sensor an interesting research challenge. Why? Because this is very, very new. Not about the installing of sensors in the underwater. When you install some kind of sensor network under the water, whatever picture we have about these oceanic environment or the marine environment completely changes. So see, even if you see a clipping of beautiful fishes moving in a National Geographic channel, your heart will feel very light, right? Because that clipping gives you a very good positive impact because of seeing those things. In the same way, you just imagine you would have been thinking of something else, but the really what is happening inside when you come to know those things, then automatically it is more interesting. Of course, when you see such data and things, you will know what is happening and how it is. And these are again expensive because it is going to be under the water, so it has to be highly IP effective. And then here, the most of the time is that the acoustic signal is the prime, what to say, the ultrasonic waves or something like that is the key sensors which we place generally. And then again, here the problems are bandwidth, signal loss, propagation delays, synchronization problem. These are some of the frequent problems we have with this kind of network. Next comes our multimedia network, which is where we had a big question. Why is this multimedia network said differently or separately comparing to your terrestrial or mobile networks? So when it comes for this multimedia network is concerned, so all our digital connections, fiber connections, which we primarily nowadays use only for the purpose of your televisions or your internet connections at home, are the prime areas that comes here. So here you can see these are designed to monitor and trace data such as images, videos, and sound. So those are the networks. We now why when it comes for multimedia network we need a higher bandwidth and good quality of service. Why we need all these things? Now we know. And generally these equipments are these networks are equipped with cameras and microphones, and this is not only for the household applications and internet applications, and these are also used for your traffic monitoring and all security purpose surveillances. All these things comes under this particular multimedia network, right? So again, when it comes for this kind of network, pre-planning is very, very essential for deployment of these networks. That is the crucial part when it comes for your multimedia network is concerned. Moving forward, and the last one is mobile network. So this is not the mobile phones what we use. This is like again the sensor nodes or sensor networks. They are just spread around, and these mobile networks or mobile wireless sensor networks move. The sense you can see the second point. After the initial deployment, these nodes dispose to gather information. The sense these nodes itself by themselves they move around to collect information, right? So this network is a hybrid network. So this has a combination of both mobile and fixed sensors. It depends, right? It has both. So this is called as mobile wireless sensor network, and this is one of the current area which there are uh, a lot of applications and areas are coming into picture. Say one small example for this mobile wireless network is that, say for example, for weather monitoring, let us consider a simple example of weather monitoring. uh, we will have stationary stations like our base stations, right, everywhere in at a particular distance or at a deterministic interval. We will have one base stations or standalone stations. We are very much aware, and now most of our cars, buses, all these are smart, right? So in those mobile devices, there will be some system which will acquire the monitor, that is the environmental data, and when it crosses this particular station, it just transfers the data. So when it comes, it just transfers the data, whatever data it has. Say, for example, from the last point to this point, when it traveled, there could be some weather changes. Now, say, for example, if you are considering you are moving from your place to Chennai or you are moving from your place to Bangalore. So when you move in a bus, your place may not have rain, but in between your place and Bangalore, there could be rain in some places. And then if you see the climate, each and every place has a different temperature, different climatical condition. So all these data could be collected in that mobile unit, and then it transfer the data to the other point. So there, what happens is that okay, that will have the complete data. This is an example I'm giving you for fixed and mobile sensors and how this mobile wireless sensor network works, right? So this is just an example. It doesn't mean that it is from Bangalore to there. It's not like it's not too far. It could be like few hundred meters, or it could be a few kilometers. It depends on the type of application which we go for. And again, the next is application of wireless sensor networks. So far, we have not seen any applications. We just saw about the types and things. When it comes for applications, we have a whole a lot of new scenario for wireless sensor applications are concerned. So here you can see it starts from your military applications and again health applications, environmental, flora and fauna, industrial and urban, right? So these again applications are all categorized in a generic way. So inside each and everything, we will also have some specific points when it comes for your smart cities and other applications. All those things comes under your urban thing. So we will see how when it comes for wireless sensors networks are concerned, how they are classifying these applications, right? So then it comes for health monitoring, environmental monitoring, flora and fauna observation, industrial automation and urban applications. So let us see one after the other slowly, right? So we will also understand what it is. So when it comes from military applications, we will have the question of how and where we can use. See, there are three main categories where these networks can be used of. One is your battlefield surveillance, then combat monitoring, and the intruder detection. So these are the three areas. And again, if you see the types of sensors which we use in each of these areas also given. When it comes for intruder detection, we will have some visual sensors and then seismic sensors. Now it starts. Just a little earlier, we were discussing about the different type of WSNs, right? So now if you see in this intruder detection, we have one sensor, visual sensor network. The other one is a seismic sensor network. So if you consider these two sensors, here itself the classification starts. The seismic sensors comes under your underground sensor or terrestrial sensor. When it comes for your visual sensors, they comes under the multimedia network. So here itself we have two different types of wireless sensor nodes. We will let us even call it as wireless sensor nodes, which means the protocols are gonna be different. The protocols you need will be different, right? So the bandwidth is gonna be different, clear. And then again you come to the battlefield surveillances. There you see the acoustic sensors and sonars. Again you have two different type of sensors. When it comes for combat monitoring, there you have acoustic sensors as well as biomedical sensors, clear. So this is why before coming to the application point, we have been discussing about the different types of wireless sensor networks. So understanding the types of sensors is very essential for us to opt or choose which type we should prefer for our own applications. And moreover, you see, under one main application, you have these three different categories. Similarly, when we go further, also you will see the different categories on each and every applicational area, and then also the sensor requirements and their networks as well. So here, let me give a simple illustration of how this works. So, for example, here this is for your target tracking. So, for example, in target tracking, here we are considering a tank. So, here from this, we are acquiring the acoustic signals and magnetic sensor signals that is being captured by your sensor module, and then it is given to the data aggregation, and then finally it takes to the data fusion. These are all some technical terminologies which we use for acquiring the data and sending. That's it, nothing else, right? So this is a simple illustration for understanding how this works. And moving further, health monitoring. Health monitoring again is a very important part. We are very much aware, and whenever we say health monitoring, we directly go move on to the smartwatches. That is what we have been seeing again. So let us see what are the different. Excuse me. Yeah. Again, when it comes for health monitoring application also, this is also classified as three systems. One is patient wearable monitoring, then it is home assisting systems, and the third one is hospital patient monitoring. So you can see there are three different categories which they categorize on first. One is, and then furthermore, you can see in detail. Patient monitoring again comes with motion sensors, temperature sensors, and biomedical sensors. And then home assisting system again, you have the position sensors, biomedical sensors, and systemic sensors. And you may ask why systemic sensor is coming into picture. See, when it comes for systemic sensors, it says about the various vibration parameters and lot many parameters that comes into picture. So when you go in detail to the systemic sensors, you will understand the purpose of the sensors. As I was clearly mentioning, each this in very simple simple architecture or simple things. But when we go in deep, the complexity of the system is very, very, very high. The sense complexity of the system is high in the sense, the essentiality of the data that is being collected, right? None of the data can be denied, and there is no time we can say that okay, no, this particular point of time to this particular point of time I will not take any data. So we cannot neglect anything as well. It's like we are creating our own mimic. It is like creating a mimic of us. Why I say that creating a mimic of us is that, see, you just consider yourself, right? If let consider your hand. If if someone pinches on your hand, you can feel pain. And if the climate is very cold, you can feel cold. If the climate is hot, you can feel hot. If you place your water into a hot water, you can feel the hotness and what not, right? Your skin has all these sensors. Can you say where it is, where the pinching is being felt, where the hotness is felt, where the coldness is felt, and how it is being when you cut, there is blood is coming out. Where is this blood is there? How is this? What is it? How come it is being designed? Can you say about the design aspect of your skin? So it is very, very crucial. When you see, when you study biology or all things, they say everything is made up of cells and fine. Then if everything is a cell, inside a cell, do we have all these sensors? No. So likewise, here when it comes for such a kind of applications, not only health monitoring I'm speaking about all the type of applications where we are trying to acquire data with the help of these wireless sensor networks and the purpose we are speaking about. Right? Everything is very, very, very crucial, and we need lot many things that is to be considered. That is why the data is gonna be exponential in all needs. Right? Fine. Let me stick to the topic, and then this is a small example with illustration of real-time electrocardiogram acquisition from an individual. You can see that there is an electrocardiogram sensor placed on this particular person over his head press, and then through wireless sensor network it reaches the nearby data acquisition unit. All right, fine. So again, the next point is environmental monitoring. So environmental monitoring, water monitoring, air monitoring, and then emergency alert. These three categories, again, this is majorly classified into three. And under each section, we have different type of sensors that have to be considered. Again, you have water monitoring, you have your RF sensors and water sensors. Air monitoring, you have gas sensors and humidity sensors. And emergency alert, you have your humidity sensors and your systemic sensors, smoke sensors, and temperature sensors. Definitely, when you go in detail into every application, you will be able to find everything. I'm just giving an overview of all those observations, sorry, all those applications. And then the next is flora and fauna observation. So when it comes for flora and fauna, what is this? Why do we have to monitor this? Yes, of course, this is also one important factor to improve our agricultural aspects. So here, greenhouse monitoring, crop monitoring, and livestock monitoring. These are the three main areas this flora and fauna application comes into picture. And in this, the crop monitoring has the majority part. I'll just give you a simple table probably. So see, this is the overall structure of the crop monitoring system. Here, this has about the soil fertility. It sees the soil fertilizer levels, the humidity level of the soil, and lot many parameters. This is one big area where the application has a very big part to play with, and also the data what you get here is more enormous, like what I was telling you earlier, like how we monitor a human being for his medical wellness. Here also the flora and fauna in this, the crop maintenance, this particular area has a very big application requirement, and the infrastructure what you will need is also very it's not only very big, actually it is essential as well. It is one important factor very similar to our health monitoring system. That is why this as a specific this has been added as a specific application without generalizing, right, by the scientists and the researchers. And then the next is industrial automation, and we are very much aware of what is all happening, because all these sensors, all the automation, all started with the industries. But wherein now it has taken the automation to the next level, not only within the industry, also outside the industry, they have started to use all these sensor networks, and we now have the unmanned delivery systems also, are also nowadays available. Again, here again they are classifying into three. One is your robotics section, that is your manufacturing part. And the second one is the logistics. And the third one is machinery health monitoring. These are the three prime areas. I'm running out of time. So three areas where the total thing is categorized, and then you can see the sensors different. Then, of course, the sensors will repeat, but with respect to the place and requirement, their characteristics will change. Say, for example, as we were seeing about the different communication protocols, if I say again vibration sensor, here the specification of the vibration sensor will vary. The communication protocol, I can be some lenient in logistics is concerned, because logistics, always it is gonna come through some vehicles in the roads or some way. So there the vibration doesn't matter much. But when it comes for a medical application, there the vibration has a very big impact. So there the sensor has to be of different characteristics. Here the sensor should be of the different characteristics. So we should uh, we should analyze the type of sensor which can be employed here, and that is very important as well, right? Yeah. So again, of course, this is what happens in the industry. So we saw yesterday. And further, urban applications. Here comes all our smart home applications, smart city applications, transportation system, and structural health monitoring. So the structural health monitoring is totally different from our health monitoring system. Here, when they say about structural health monitoring system, here they speak about the buildings, the infrastructures, dams, your bridges. That is what here they call it as structural health. All right, fine. So here again, you can see that we have one separate section for smart homes. The smart cities is separate, and then transportation is system, because when you come for smart cities, we just include everything. Transportation comes into it, smart homes comes into it, and most of the time we never think about the structural health. So that is one important area which has to be given more importance. So when it comes for wireless sensor network, that also has been given a point, and then people do a research or do lot of study over this, because they are all the public entities which has to last long. So here you can see there they maintain, there they measure the corrosion, the strains over that, and a lot of parameters are there, right? So this is one important, again, another area where we have the application of our wireless sensor networks. Moving further, so far we have seen about the different applications of wireless sensor networks in a different context. And in all these, as I was telling, in all these, again there is one more way of classifying these wireless sensor networks. Say, for example, these networks can work as event driven, right? Event driven. Say, for example, if there is an event, say if there is a forest fire, as we have been telling about the terrestrial area sensor placement, if there is a forest fire, then the sensor network or the sensor node, from there we will just get data and say that okay, this is being happening there. Then the particular concerned department will receive information, and they will act accordingly. Or if it is there's going to be a huge flood, right? So those are examples for your event driven. Say in particular area there is too much of traffic is there, that is also an event area. Area has too much traffic, so that information will be sent, so they will be diverting the traffic. So this is something, when something happens based on that action will happen, that is called as event driven. And this event driven is applicable in all the application areas which we saw earlier. It could be for your medical applications, or it could be for your, say for example, event driven for medical. If you consider one person is having a sudden rise in his blood pressure, then that is also an event driven, right? Or when it comes for your smart cities, I told you an example. And then what else? Industry, there is a heavy vibrations in a particular machine, that is also an event driven, right? So likewise, we can use these classification of application in also in all the above set applications. Why are we considering this? Is that this also has to be concerned when we design a network. And the second one is going to be a query driven network. What is this query driven? If there is somebody asking something, or if there is a request for some particular action to be done, right, then that particular network will work on it and that particular action will be taken. So this is called as a query driven wireless sensor network. And the third one is going to be a time driven. So based on time, this is a periodic process. So this should happen for a certain it should repeat at a certain time interval. So that is called as a time driven wireless sensor networks. And the last one is going to be a hybrid one. So hybrid, it's very much we are very much aware. Any combinations, it could be an event driven and time driven, and then query driven, time driven, or any combination could be there. That is called as a hybrid wireless sensor network. So this is also one type of or this kind of application requirement as also to be considered while we go for any wireless sensor network. And then comes the low power wireless sensor network. What is this low power wireless sensor network? Is that nothing. The only thing what we add here is this low power, nothing else. So here the wireless sensor network should consume lesser power. So that is the first thing. We should have an energy efficient communication protocol, and then sleep wake mechanism and duty cycling. What is the sleep wake mechanism? Is that earlier I have been telling you about the redundancy of data, right, continuously. So it should work like, for example, in time driven, I should collect data only between this period and this period, or at every such interval. So if I have to collect the data for every 30 minutes, once in a 30 minutes, I can just wake up, collect the data, and then again go to sleep mode, right? And since it's a resting period, in that resting period, the device, the sensor, nothing will work. So that is called as sleep wake mechanism. And to cycling as well. So that is also possible with respect to your sensors are concerned. So that is one another parameter. And then AI for power optimization. That is where we can go for this. Not only for power optimization, also node selection, and then which node we should select, which is very effective. Like lot many things also can be done with AI. But here, when it comes for the low power sensor networks are concerned, we can use AI for low power optimization, as currently we are progressing towards I 5.0, that is industry 5.0 sensors, which will have its own AI mechanism to do all those things. So in such a case, we can use this for the power optimization. With all the applicational requirements we have discussed so far, now we might understand why we are speaking about the low power sensor networks. Why should we should have a low power WSN, right? And again, this is I just will pass through these slides again, because with respect to whatever we have seen, what are the general sensors we will require. These things we just saw yesterday, just for your recap. These are the general sensors which we use, and I'm just giving it just for the recap. And then applications of the different sensors where we have it, and then we can again use the same MIT app inverter, because all these parameters we have been seeing now, vibration analysis and all those things, all, even whatever application we saw today, our mobile phone sensors can tackle many of these. I will not say all of these or most of these, but many of these can be tackled. And when it is possible for us to do with a single app, we can again go for the same smart. We can just create our own app, and then we can do that. And then Arduino Cloud is again one another platform where you will be able to get all the data. I'm just skipping all this because we have seen all those things earlier. And then challenges and future trends. Yeah, this is one main challenges all the parameters, data acquisition, processing the data, analyzing the results. This is always a challenge because the quantum of data what we get is more. And then to be very simplistic, to expand the challenges, we have the same thing. The quality of service is a very big challenge. And reliable data transfer, because the data transfer is huge. The contact reduction, which node are we getting into? That is again a challenge. Mobility oriented diet management, energy consumption, and the location. That is identifying. These are all some of the simplification. Whatever we said earlier, I'm just giving you in a simplified way. That's what it is. The future trends, what we have is that AI driven data processing, and then machine learning for anomaly detection, and then edge computing and IoT integration. These are the future trends of the WSNs. Fine. And conclusion. So, of course, with all these, whatever we have seen, the first thing I would like to conclude is that these networks, the usage of wireless sensor network will provide remarkable advantages for various human activities in our day-to-day life. The continuous evolution of the technology enables us to expand the current sensor network, should expand the current sensor network, and of course we believe that cost will also come down, right? So these are two things I just like to conclude with all my presentation. Of course, this is a very good topic or very good area which will give us a lot of information, which will enhance our living. And then again, but again, the cost of investment is also one problem. So I believe the evolution of technology will come down. That's all from my side for the day. And then yeah, the applications keep on going. That's it. So that's all from my side for the day. The session is open for questions. Hope I have done in time.
Thank you, Sandor sir. Thank you very much. Participants, do you have any query? Kindly type it in the chat box.
About the sensor modules, they are of course in the form of chip. Especially Bosch has come out of a lot of chips which have, or microchips I would even say, which has the capability of sensing multiple data. Some BME series, I'll just type it up. BME series of sensors you can go. There are 680, 820, lot many things are there. Those are all very very micro level chips which has the capability of acquiring more number of data with lesser power consumption. So that is one application I would like to, one sensors I would like to quote here. Of course, there are a lot of sensors that coming in as small dip packages. Even we have micro sensors now. MEMS, we have MEMS. I hope you know we have MEMS. Wireless sensor networks in IoT network. What are the possible research prospects in wireless sensors in IoT networks? So for when you when you ask about the research prospects, first of all, the wireless sensor networks and IoT are like they are very much into each other. They are very much together, and you could have seen from the presentations, all these areas are open for research. You can take any one of the slide, and if you start doing research, and then you can do research for 10 years, and then you can even come out with even many papers as and how you want. So each and every slide which we have here in most of the cases, and the applications part is concerned, have a potential scope of research. So there are a lot of scope. There is an infinite scope of research. See, underwater sensors be used for checking water quality. See, checking water quality will be one of the parameters that these underwater sensor network will do, because they are for a very higher purpose. So for checking the water quality and other things, there are a lot many small sensors are available. In the sense, small sensors in the sense, comparing to these underwater sensor network sensors, we have simple sensors which can do all the salinity tests and water quality checks. Those can be done, of course. Of course, to answer your question, yes, the answer is simply yes. But it is that underwater the sensors are not required for checking water quality. That is one point I would like to add. Thank you.
Participants, any other queries? Okay, sir. Thank you very much. Dr. Sandosh, thank you very much, sir. Thank you for sharing
Thank
your
you, sir.
valuable thoughts and ideas with among us. And thank you for spending your valuable time with us. Thank you very much. Thank you very much, sir.
Thank you, sir. I thank you for the opportunity, sir. Thank you, institution and your management, for giving me this opportunity yesterday and today. I wish you a very good luck for all your sessions to come in. Thank you, sir.
Thank you very much, sir.
Thank you, sir.
Thank you, sir.
Participants, kindly wait. Don't leave the meet. The second session will start within 5 minutes. Participants, don't leave the meet. Once again, I welcome you all for the second session of this FDP. So, in this session, it will be handled by Mr. Ayyappa Srinivasan. So, I just want to brief Mr. Ayyappa Srinivasan's valuable experiences and his research areas. First, Mr. Ayyappa Srinivasan has completed his BE in Electrical and Electronics Engineering in the year of 1999 in National Engineering College. He completed his Master of Engineering in Power Electronics Drive in the year of 2008 in Government College of Engineering, Tirunelveli. Currently, he is pursuing his PhD in the area of renewable energy and emerging trends. Totally, he is having 15 years of experience in teaching. Right now, he has 25 publications in the reputed journals and 15 patents. So I welcome Mr. Ayyappa Srinivasan and I hand over the session to him.
So, very good evening to one and all present here. I am Ayyappa Srinivasan, Assistant Professor of St.Mother Theresa Engineering College, going to present you the topic of sensors in electrical engineering. So, let me present my PPT now. Is my PPT visible? Is my PPT visible to everybody?
Yes, sir. Yes, sir.
Okay. So let me start. So actually, what we are going to discuss about the sensors in electrical engineering, and we are going to the contents of today's topic are capacitive sensors, inductive sensors, force or stress sensors using quartz resonator. So these are all the main sensors that are being used in the electrical engineering field. So let us see one by one. First, we are going to see about capacitive sensors. The capacitive sensors, in this we are going to see the following contents. First is capacitor and capacitance. Second one is capacitance transducer. Third one is displacement transducer. And fourth one is proximity transducer and level transducer. Before that, what we have to discuss is what do we mean by transducer? Transducer is actually a device that converts any signal into electrical form. That is in sort of electrical engineering. But ஐயோ நீ ஐயோ வர FA wait. Oh, participants, kindly wait. So, is my excuse me, is my full screen is visible? PPT or in the PPT form it is visible?
Yes, sir. Yes, sir. Visible.
Full screen visible, isn't it? Okay, so let us see about what is transducer. Transducer is one which converts any signal into any form of signal into electrical in nature, that is in our electrical perspective. But when it comes to general thing, it is a device that converts one form of signal into another. So let us go in with the electrical signal, so electrical perspective. So this is first one. So first let us go, we are going to see about capacitive sensors or transducer. The next one. Okay, so let us see the next thing, that is what do we mean by capacitance or capacitor. Capacitance is a property which can hold the electrical charges in the material. That is the capacitance. Now, what do we mean by capacitor? That is, capacitor is a device which can, the device that can hold the charges. The property by which the device can hold the charges is called as capacitance, and the device that holds the charges in it is called as capacitor. Now, in my presentation, you can see that is the device that has two parallel plates. It has one side positive charge, another side negative charge. So kindly note, there is neither positive or negative charge. That is, if we give a voltage, the electrical flux lines will start from one plate to another. So the plates from which they leave are called positive charged plates, and the plates that in which into it enter is called negatively charged one. So this is the capacitance and the property as well as capacitor. So fundamentally, C is equal to Q by V. That is, capacitance equal to charge by voltage. So where C is capacitance in unit farad, Q is the charge, and V is the voltage. So the capacitance depends on the shape and relative position of plates. So it is 1 farad. Now another formula, that is, we can see the next formula for the capacitance. That is, it is epsilon naught A by D. What is epsilon naught? We have to understand. So epsilon naught is the permittivity. What is permittivity means? So a device, a capacitor will allow, a dielectric will allow certain amount of flux lines through it. So if it is open space or free space, the lines of flux will flow through it. It will be lesser in number. And A is the area of plate, D is the distance between the plates. This is the thing. So this such a sort of device is used in the with a coaxial cable, where inner cable will move into within the space of outer cable, that is through a dielectric. The next thing is important one is dielectric constant. What do we mean by dielectric constant? Actually, this term is usually used by physicists. That is, physics people are using this term. We, the electrical engineers or electronics engineers, what the case may be, the term that is to be used is relative permittivity. So in the previous slide, I told that from positive plate to negative plate, if it is a free space, the lines of flux are flowing, right? But where the lines of flux flowing through the free space is always less. So in order to increase the flux line and then hence to increase the capacitance, what we usually do is we insert certain dielectric material in between the plates. So there are charges in the dielectric material. There are charges. These flux lines flow from positive to negative plate. So these charges are aligning within, whenever voltage is applied within the dielectric, the charges are aligning themselves. That enhances the capacitance by a term called K. This is called dielectric constant. Originally, in the previous slide, we saw that it is epsilon naught A by D. Whenever it comes to our dielectric constant, K epsilon naught A by D. K is the actually dielectric constant, and we should use this term as relative permittivity. So the next one is the capacitance transducer. We saw already what is a transducer. Transducer is a device which converts one energy into electrical energy, electrical form of signal. Sorry, it is not energy. When it converts one sort of signal into electrical signal, that is our transducer. So in case of capacitive transducer, any force or pressure or any other thing is converted into electrical signal by means of certain thing. Right? So we will see it later. So for a good capacitive transducer, the capacitance should not vary with respect to temperature or pressure or humidity. It should not be affected by environmental factors. If so, it is not a transducer and it will be erroneous in nature. Now, let us come to once again the previous slide. That is, we saw that C is equal to epsilon naught A by D. So, the capacitance has to be varied for the transducer purpose. For this, we have to either vary epsilon naught or epsilon, whatever may be, it is fixed. So, we have either to vary the area or the distance between the plates. So, how we can vary? So, accordingly, we have two things in a display, in a sensor. Actually, the capacitance sensor transducers are mainly used in the measurement of displacement. By displacement, we can directly calibrate it into the terms of force or in terms of pressure or some other thing, whatever it may be. So, what we are measuring is by displacement. For measuring displacement, we use two things. That is, one is we are varying the position of the inner dielectric. So, whenever the inner dielectric position is varied, what is happening inside the capacitance is electrical flux lines are varying. So, actually, when electrical flux lines are varying, then the voltage across the capacitor is varying. This is one sort. Another sort, what we can do, but usually it cannot be used in most applications. So what we can do is we can change the area of the plate. So effective process is to measure the displacement is moving the dielectric, that is inner dielectric, in between electrical field. This is one thing. And the plate distances can be varied. This is another thing. So we can do these two things only. So area of flux, area of plates is there, but area of flux, that can also be varied, and distance between D, that can also be varied. This is the thing. So the next one is we are having one such a sort of example. This is an arrangement how the capacitance is varied. See, the person is varying the capacitance by moving the dielectric within inside the plates of capacitor. The plates are not seen here. At the top side, one plate is there. At the bottom side, another plate. So we can vary the distance between the plates or the dielectric. Actually, it is shown as a metal, but it should be a dielectric. Here there is one dielectric. This dielectric position can be varied inside and outside. So this is the thing. So we can vary the area of plates and we can vary the displacement between the plates or position. We can vary the position of dielectric. So now we come to the applications one by one. What are the applications of capacitance level sensor? They are mainly used in measuring the liquid levels, right? Liquid levels. We can measure the liquid levels as well as even certain solid levels. So in case of fan, you are having a capacitance. The dielectric is usually in a powdered nature. So for certain solids, but it should not be a pure solid. It should be in a granular form, powdered form. You can take like that. So what we can do? So what are the applications of these capacitive sensors? Is one, they are measuring the liquid level at high liquid metal level at high temperature. So the temperature of the liquid metals is high. So we can measure the level of the liquid metal. Actually, the liquid level metals are usually dielectric in nature. So at the top and bottom side of the container, simply we are fixing the plates. So whenever the liquid level rises, what happens is, so if the say consider the container is part of the liquid level, part of the container is liquid, and above it is air or free space, whatever you can take. So then the capacitance will be somewhat, some 2 farad, let us have. So if the liquid level increases, the dielectric constant increases. Hence, what happens actually? So the capacitance increases, the voltage will decrease in order to keep the charge constant. The second one is liquid gas measurement. So at low temperature, first one we can measure even at high temperature. The same thing is with liquid gas. So the gas is in the form of liquefied gas. The third one is corrosive liquid like acids. These are all the applicable. This is the level sensing application. So the next one is interesting in nature. We are having intruder alarm circuit. I hope the students at the diploma level or UG level will be doing their projects in this area. So intruder alarm. So whenever a thief enters into your house, the burglar alarm will give the sound. But we can simply have this device, just fix plate between two walls. So, and the two plates are earthed. Now, when the two plates are earthed and we are connecting it with a voltage source as well as as well as some speaker or some other voltmeter or some alarm circuit, right? So there will be a voltage and this voltage is taken as reference. So whenever a human being now enters, he is having some two capacitance in his hand. That is, when he enters between the plates, his capacitance with respect to ground is given as CB and his capacitance with plates is given as CA. Originally, when the man was not there, these capacitances were not present. When he enters, the capacitance changes, automatically voltage changes. So when the voltage changes, the alarm, burglar alarm will give an alarming sound. So this is called as proximity sensor. Why it is called the capacitance? This sort of capacitance sensor is called as proximity sensor. Why? In the it senses the proximity of a human being or proximity of a dielectric. As you know, the human body is a dielectric in nature. So proximity, if there is any dielectric in its proximity, this capacitance sensor will definitely sense and it will change the voltage accordingly. This is one sort of, another sort of application. First one is displacement measurement application. Another one is proximity. That is, the next application is proximity sensor, proximity application. The third one is actually another interesting one. What we can use is the capacitance, the capacitor plate. We can have one plate and the one plate will generate its own electric flux, and the dielectric material is placed near the dielectric material or some other thing. It will be placed in the vicinity of the electric field. So what happens in this is, now the flux link with electric flux links with this metal, or what to say, if it is a cloth, it will be having some sort of relative permittivity. If it is metal, it will be having some lesser relative permittivity, because in permeability in metal is a permittivity in the metal is less. If it is a sponge, its dielectric relative permittivity will be higher. So accordingly, the flux will be, electric flux generated from the plate will be affected. So the voltage in the plate accordingly changes. Another one application is robotic application, in which the handle of the robot is fixed with a capacitor and the human being is, and it is provided with a shield. If it is not provided with a shield, when the human being comes, the capacitance will not be affected. So the shield is provided in order to affect or change the capacitance Accordingly, the robotic arm moves. So the very next very interesting application of the capacitive transducer is electronic weighing balance. So in the electronic weighing balance, what happens is it was used in the olden days, that is when such a electronic weighing balance was introduced in the market. So first used was the capacitive transducer. So accordingly, whenever we place a weight, what happens? The relative position between capacitance plate changes. We are applying a voltage across the plates. So whenever we place the weight, the relative position between plates changes. So the voltage across the plates changes. Accordingly, the capacitance changes. This is the thing. So these are all the very interesting applications of capacitive transducer. Now let us coming into the inductive sensor. So what do we mean by inductance? That is a property of electrical conductor when it carries current it should not be said as create, to form a magnetic flux around it is called as inductance. So in a wire, when current flows, it forms a magnetic flux around it. This sort of the property of electrical wire is called as inductance. That is, it can create a flux by which EMF can be induced. This is the reason for telling it as inductance. So whenever magnetic flux changes, electrical wire is carrying current. So if the current through the conductor changes, magnetic flux, if consider a wire, it is placed in alternating magnetic field. So whenever the magnetic field changes, the two things will happen. The conductor will experience a current because of the third point, electromotive force induced in it. So we know that the electromotive force that is called as EMF is directly proportional to the rate of change of flux. So the one thing we have to understand is the fact that if the only main thing that the EMF to be induced by the conductor is to be alternating current should be flowing through the conductor. When it is a conductor, if it is not, what will happen? The EMF will never be induced. That is the thing. Now let me consider a voltage is what is the EMF induced in the coil. That is, it is given by V is equal to minus N d pi by dt. Usually d pi by dt is the formula. Why we are using N is the number of turns. It is the number of turns. So how the EMF, the voltage can be varied. So automatically we can see by varying one flux. Second one is area. So flux density can be varied, area can be varied. So let us have because the inductor coil, the coil is wound with the number of turns, so the N cannot be changed at all. So if the voltage can be changed only by varying the flux or by varying the area. So let us how it can be done. So this is the main factor or main property that determines the inductive sensor. Now moving source. Now how the voltage is induced in the coil. So moving the source of the magnetic field, that is a core or some other thing, either core or the coil has to be moved, but the coil cannot be moved at all. But it is done in DC generator, everything. But moving the coil is somewhat tedious task. So in order to avoid that, moving the source of magnetic field, that is by moving the core, we can vary the magnetic flux, hence EMF can be induced. Or otherwise, the another thing possible is we can vary the current in coil, by which flux will be varied, so EMF will be varied. This is by which B can be varied. Now how A can be, that is area can be varied simply by varying the dimensions of inductance. But in higher electrical applications such as choke or some other thing, this is not possible. So only by varying the flux, EMF can be induced. But in lower level applications, in certain level applications, we can vary the inductance by varying the their size. The next one is the induced voltage is proportional to rate of change of flux. That is, when the current changes, flux changes, so induced EMF changes. So as I told earlier, the voltage is essentially zero for DC, because the DC never varies with respect to time. It is constant with respect to time. So the voltage increases linearly with rate of change of current. So flux, rate of change of current, in the sense when current changes, flux changes. So EMF induced changes linearly. That is, it is linear in nature. This is the main advantage of inductance. As we know, XL is equal to 2 pi FL. So this is the main advantage of the inductance. So the induced voltage is always in the direction opposite to the rate of change of flux. That is, the EMF induced will be in direct opposition to the applied voltage. This is what is seen in the motor, and by which the motor rotates. That is, we apply voltage to the armature, and the EMF, that is, the EMF is induced in the motor. Even if we give current to it, that EMF is called back EMF. It opposes the applied voltage. So this is the main reason for the motor rotation, and this is the thing. Induced voltage is directly opposition to the applied voltage. So once again, inductance is also a proximity sensor. As we told earlier, the proximity sensor is nothing but the between the inductance or the sensor and the object and the target will no contact at all. So it will sense whether in its proximity some other things are there. That is why it is called as proximity sensor. The capacitive proximity sensors are usually high cost. So as they are usually high cost, we are going in for inductive proximity sensor. It is used to detect mainly metal object. That is the disadvantage of this inductive proximity sensor, because when we have, suppose we have to check whether it is a cloth or sponge or what is the material present, the inductive proximity sensor will not sense. Only it will sense metal object, and based on the metal object, say if it is copper is also a metal, iron is also a metal, or some other thing. So aluminum is also a metal. Whatever the metal, according to the metal, it will sense and create voltage, and it depends on the type of the material. The next one is the electrical current. This is the principle. Electrical current generates the magnetic field. That is, whenever the current flows through the conductor, magnetic field is created. So you can consider a cycle dynamo. So it rotates in magnetic flux, and as it rotates in the magnetic flux, what happens? EMF is induced. So this induced EMF is the chief reason for flow of current. So we are for transducer application or sensor application, what we are going to do is we are going to convert pressure or force or some other thing, or rotation or some other thing, into voltage, and the voltage is going to be measured, and it is going to be calibrated in terms of the quantity being measured. This is the applications of inductive sensor. So they are mainly used in metal detector. Metal detection is the main application. Traffic light, car washes, host of automated industrial process, another. So let us first see the traffic light, how the traffic light is glowing. In olden days, some applications were using inductive sensor. So inductive sensor will be placed in busiest junctions. So as we know, in olden days, cars and buses and each and every vehicle have some iron object. So it will sense the iron object's presence, and accordingly, according to the amount of the number of iron object, it will, the voltage of the inductance sensor will be definitely varied. So as the inductance voltage is varied, then according wherever the vehicles are high, the inductance sensor will give high voltage. So the green signal will be directed towards wherever large amount of vehicles are there. Wherever small vehicles are there, the inductance, the voltage induced in the inductor will be, inductive sensor will be less, and they should be stopped till sufficient vehicles come and accordingly high voltage is achieved. So this is one sort of metal detection in traffic light signal, but nowadays it has come by using image processing or some other thing. We are having several other applications, so they have changed now. The inductance sensors are mainly used in metal detection. So these are all the inductance sensor, inductive sensor. See, there is a metal and the metal is wound with coil around it. So the metal is wound with coil around it, and this arrangement is placed in a casing. So if we put this application in a fixture and we are placing a metal or some other thing and supplying voltage to these contact points, then it gives a voltage in it and it provides a pickup signal, usually in the form of pulse. So inductance sensors are used for that. So let us see one by one applications of inductance sensor. The inductive sensors are used for mainly in vibration measurement. Now, but however, nowadays we have turned our attention into quartz that we will be discussing in the later stage. So in the vibration measurements are the main applications of inductance sensor. What they are, how they are measuring vibration. We can know that we know that whenever a motor rotates or whenever the thing happens, a vibration is there. So if we put, so consider the vibrations are two things, two types of nature. One is the linear vibration, another one is rotational vibration. Angular, let us say it is angular, because in control systems we are having linear system and angular system. So linear vibration, angular vibration. What is linear vibration? If the vibration is in a linear way, that is, it moves up and down. So if the rod moves, vibrates in up and down matter, up and down way, then it will be giving a linear vibration. So consider this point, the rod is moving up and down. So the coil is wound around that and inductor is wound around that. So a voltage is applied across the inductor. So as the voltage is applied across the inductor, what happens is the EMF is, that is, as the rod moves, that is, the vibrating object moves and EMF is induced. This induced EMF is used to calibrate it in terms of vibration. Next one is this is another thing. It is actually angular vibration. It rotates as the rotor rotates. As the rotor rotates, then the coil is vibrating. That is, in the coil, the rod moves here and there. So it is converted into linear vibration at all. So it is moving here and there. So automatically the EMF is induced in it. So this is the another sort of thing. The next one, how the metal objects are detected. This is actually transformer coil detection, right? Transformer coil detection means transformer coil is wound on the silicon, that is the steel object. So the transformer coils are, how many transformer coils are there, how many windings are there. So we are having an inductive transducer present here. Accordingly, the copper is sensed by the inductive transducer and the inductance of the voltage, that is, the voltage is changed. Whenever the copper is moving, the voltage is changed due to change in flux. So one point I want to say here, emphasize here, that is, the flux changes. The flux change is nothing but it is due to change of mutual inductance between the object as well as the coil. So whenever the mutual inductance changes, the EMF induced changes. This is the main property that we have to understand. So automatically what the pickup device will do is it will sense the presence of copper, and it will say the flux flowing, that is the flux created by flowing through it will change. So mutual inductance changes and EMF induced changes. This is one main sort of application. Madam, one Deepak Singh, sir has said that kindly keep the PPTs in presentation mode. So, sir, actually, what has happened is some technical glitches there, sir. So, I am continuing with this mode. Okay, let me continue. Now, another sort of metal object detection. So, another sort of metal object detection is that it is the metal objects can be detected by the inductive sensor. So the metal objects are there. So whenever we have to count, say some industrial application require how many bolts or nuts that we have manufactured today. Simply in a conveyor, the bolts are placed. So the pickup sensor has a winding wound through it, and voltage is applied, current is flowing through it, created whenever the metal process flux is changed. So a voltage is induced and a pulse is produced, and the pulses are counted directly by the counter. So this is another thing. So the inductive sensors mainly find applications in robotics. So in a robot, we are using a pickup device. So in the pickup device, whenever it moves here and there, it will sense if there is any metal object present near it. So handling and robotics application, the inductive sensors are mainly useful. Now let me show you a typical inductive sensor. It is shown here. So actually it has a coil and signal evaluator, that is a trigger signal, and a switching amplifier. What is that? It is a switching amplifier. It amplifies the signal. So let me how the inductive sensor. This sensor is usually, this is the original inside. What is there? It is a sensor that is present here. So we can see. So it is the inside cut part of the inductive sensor. So how it works? It is the thing that we have to see. So it is explained in the slide 28 and 29. So what are is they are having an LNC or LC oscillator. That is, it has an inductance as well as capacitance. So whenever and capacitance are connected in parallel, what happens is inductor stores energy and releases the energy to capacitor. Once again, capacitor releases the energy and gives it to inductor. So vice versa it is happening. So what happens is, this is the principle that is we use in LC oscillator. So this electronic LC oscillator, this is high voltage device. This is somewhat high voltage device. So the LC oscillator creates an sinusoidal, purely sinusoidal, but high frequency signal, right? So whenever the high signal is given, a magnetic flux is produced. So the production of magnetic flux by the oscillator causes it to be flow outwards this object. So at the same time, the magnetic flux also flowing through signal evaluator or some other thing, trigger circuit. The trigger circuit converts this into electrical signal and produces a trigger voltage, right? Produces a trigger amplifier signal. For this amplifier, it produces a trigger voltage, trigger signal. So it is normally, actually under normal cases, consider this target object or this metal object. In our practical application, this metal object is not there. Then the magnetic flux will be sending it the flux through the signal converter to the signal converter. It will be sending it to signal converter. The signal converter generate the signal and it will be amplifying the output, right? So it will be amplifying the output, and hence what will be happening is the normal voltage signal, that is the normal voltage signal will be present in the output. Next one, now let us consider now what happens if an object is created. placed here. Sorry, a metal object is placed here. When magnetic flux is coming out of this oscillator inductance, then what happens is it meets with the target. In the target, an eddy current flows. So automatically the magnetic flux is affected. Accordingly, the trigger signal input is affected. Accordingly, the input to the amplifier is affected. Accordingly, the voltages, output voltages vary. So originally when it was not there, was the reference here. But when the reference changes. Accordingly, the difference is the indicating the presence of the object. If it is copper, it will be increasing by to certain amount only. If it is a pure steel or iron, the voltage change will be higher. This is the main application of inductive sensor that we are saying. This is to be actually mounted at the vertical position in an typical application. Now, a main thing that is to be seen here for an inductive sensor is that is what distance it can sense. At what distance it can sense, it is the main thing. One is nominal sensing distance. What is nominal sensing distance? Yes, is that the inductive sensor is placed here. So when the inductive sensor is placed, a metal object is placed near it. The distance up to which the inductive sensor can detect or sense the metal without considering temperature or external influences such as humidity. We should not consider external influences or humidity or temperature or other thing. Only we have to consider the how up to what distance the inductive sensor can measure the detect the object. It is the nominal sensing distance. For any inductive sensor, it is up to 1 millimeter. So the next one that comes is effective sensing distance. Here we are taking for calculating the distance, we are taking into the account of temperature and humidity at all. So for the first one, if it is 1 millimeter is, but the effective sensing distance will be somewhat greater. At least it will be 1.2 or 3 millimeter. So a very good inductive sensor should not be affected by external influences. It should not be affected by any the humidity by which the steel rusts or such other things. It should not be affected. So the next one, the main applications of inductive sensors are also displacement measurement. See, in the capacitance also we saw about displacement measurement, but in the inductive sensor also we are seeing displacement measurement. But in actual cases, we are using only inductive sensor because all the aspects that use capacitance in its principle cost higher. So if you refer to some electrical machine design book, there is our high voltage engineering book, you will find a machine called electrostatic generator that is useful for high voltage application. Its cost is high. But by electromagnetic generator, that is normally we see the alternator or the DC generator, their cost is less when compared to that. So whenever inductance applications are used, their cost is lesser than capacitive applications. However, the inductive applications will consume high power. The capacitance applications will consume somewhat lesser power. So let us consider what is happening with displacement measurement. So let us the displacement measurement, how the displacement measurement is done. So the inductor, that is why we are going in for displacement measurement by the inductors is the reason is their fastest response. That is, at the start we give the input, they will respond immediately. The change in voltage is high, so they respond immediately than the capacitors. This is main thing, right? The second one is the output voltage is proportional to the distance between the sensor and the object being detected. The proportionality is very high than the capacitive transducers. This is the another thing. That so this main application has made it the inductance, that is the displacement, to be measured with inductive sensors in a greatest way. So there are some sort of inductive sensors. One is travel position displacement. It uses single coil, that's all. Within the single coil, the object moves. So what happens is the displacement is directly measured. Not only displacement, we can say the position or travel. According to the application, the term will change. The next one is very interesting in nature. That is, a cylindrical application is that it provides a flux through around it. The cylindrical inductive sensor provides a circular flux around it. So whenever the object moves through the area of flux, kindly note, whenever the object moves not through the sensor but through the area of flux, the eccentricity or the effective diameter, I have provided it is here as a dia, but it is not the diameter, it is effective diameter of the flux will vary. What happens if effective diameter varies? Then the EMF is induced and the voltage will change. This is the another property. Let me come to the third point, size comparison. So there are 2 or more coils, 3 coils, let us say. So whenever the object moves between 2 or 3 coils, then according to the size of object, the EMF will be induced. This is another thing. So 3 sort of applications we are having. The main inductive sensor that we are well versed is linear variable differential transformer, that is otherwise called as LVDT. So the LVDT has a single coil in it. The LVDT has single coil in it, and that is primary, and 2 secondaries are there. So the primary is supplied with usually AC supply, and 2 secondaries are linking with the flux, right? 2 secondaries are linking with flux. Now what is happening? That is, the metal object is in the form of core, right? The metal object is in the form of core. The core is moved in between the primary and secondary. So whenever the core is moved, so originally if the consider a core is not there, a displacement core is not there, then the from what to say, this flux from primary will link with secondary. This is the one thing. All the 2 secondaries, when the core moves, the linking flux changes, accordingly EMF is changing. Okay, it is linear variable transformer. Why we are using the term differential? The connection of secondary is in the form of differential in nature. That is, EMF induced is proportional to difference between 2 secondary voltages. That is the main thing. Why we are using the differential aspect? Why we are not using in adding aspect? That one has to understand. That is, the voltage must be less so that it can be given to any electronic amplifier. So amplifier, op amp or some other thing we will be giving, and it has to be given to some electronic amplifier. The signal must be feeble. It should be lesser, or even it is expected to be feeble. That is why we are connecting it in differential nature. So see here, the voltage present here and present here will be subtracted, and the difference voltage will be obtained here. This is the phase opposite, the reason for linear variable differential transformer. This is the reason. So the LVDT is shown in this photo. So kindly see this photo. Actually, what they are doing is, it is having a simple steel ion, that is ion, and the what to say, the single primary and 2 secondaries are provided in the top side. So in between, so in the middle there is a gap in this steel ion. So beneath that, the metal is variable, the core is moved, so it cuts the flux and differential voltage is induced there. So one another thing, in transformer we might have studied. So whenever voltage flux is given, voltage is given to primary, see, it will link, flux will link with secondary, and if a load is connected in the secondary, the flux will again link with the primary to oppose the flux produced there. This is what might have seen. So, but it is not the case here, because the flux linking from this, because there is no load. So in this coil, only in the coil we are connecting it to a, say, voltmeter which has high impedance. So all the fluxes linking with the flux linking with primary to secondary, if it suppose links with secondary to primary, both fluxes, that is from secondary 1 and secondary 2, will be opposite in nature, because they are connected in differential manner. They will nullify each other in the primary. So they will not affect the secondary flux, will never affect the primary. The next one is quartz resonator technology. The last one, the quartz resonator technology. So it has completely replaced the capacitance transducer, right? It has completely replaced the capacitance transducer. It is mainly used in digital computers and digital control systems, right? They have, why we are going for that? We are going for this because they have high accuracy. They are inherently a digital sensor, right? They are, because their accuracy is very, very, very high. So we are going in for this quartz application and resonator application, and hence the quartz sensor is used to accurately measure, right? The quartz sensor is used to measure pressure, acceleration, angular rate, temperature, weight, force. So we can see mainly the quartz sensor is used to measure the force, right? Mainly used to measure the force. We can understand. So the force is directly proportional to what? Pressure. So automatically it can be calibrated into pressure. Also, the force is directly proportional to acceleration, because F is equal to mass into acceleration. So as the mass into acceleration, we can once again measure the acceleration using quartz signal. Also, we can measure the angular rate. Angular rate means angular speed, right? Angular speed also can be measured. Likewise, temperature can also be measured. The temperature, that is, when the quartz is having, say, applied with certain temperature, it will elongate, right? So accordingly, the voltage will vary. That I will discuss later. So weight. The quartz will be used to measure weight. That we have seen in the previous slide. That is the weight balance. In this, earlier I told that we are using capacitive transducer there. Originally, it was the capacitive transducer, so it costed it. But when it comes to quartz, or wait a minute, please. Whenever it comes to, okay, thank you. Whenever it comes to quartz, the cost is also less, as well as the accuracy becomes high. The quartz principle is also very much similar to that of, what to say, the capacitance, right? So so this is the main reason the capacitive transducers have completely replaced not completely, almost replaced the quartz sensor. It is used as load cells also. So this is the thing. The next one is quartz crystal resonator. They convert mainly what is the use of quartz crystal resonator? That is, the quartz crystal resonators are converting analog forces into almost digital pulse. If you take capacitor, a capacitor will be providing AC. Capacitor, AC, if it is given with AC, it will provide AC, or if DC, it will give DC. If you take inductance, only it will give the AC, it will not be giving DC. So we have to, whatever may be, in the both cases, we have to convert the output of the sensor into digital signal by using ADC, analog to digital converter. But in case of quartz, it will be very much advantageous in nature. So if we use the quartz, almost digital pulse will be obtained, and the voltage resolution will also be high. So very much higher output resolution. The resolution as well as accuracy is higher. So let us now discuss about what is the reason for quartz being used. Or piezoelectric. Quartz is originally called as piezoelectric transducer. So what is the reason for using the piezoelectric transducer? The piezoelectric transducer is used mainly pressure charge generation. What is pressure charge generation? When we apply the force or force or some forces, nothing but we are supplying some, giving some force on an object. If it is high force, that is if it is given with some pressing force, it is called as pressure. So the pressure, whenever it is given with pressing force, then the charge is automatically generated. Here I have written as generation, but it is once again not generation, it is realignment of charges. One thing we have to know. So this is piezoelectric transducer. So the piezoelectric transducer, nothing but it creates. So the piezoelectric transducer creates, what it creates is it converts the force or pressure into charge. Next one is anisotropic. Right? Isotropic means anisotropic means it is direction dependent. That is, the quartz are in what to say, the piezoelectric crystal, the alignment of charges is based on the direction of applied force. This is another thing. Right? Right? Then the another one is the voltage depends on velocity of wave propagation. The velocity of the force propagation inside the quartz crystal. So inside the quartz crystal, how the force propagates or how it presses will be giving the change in output voltage. Another property of the quartz is the hardness of the material. How hard it is. It will be quartz material. Thermal and electrical conductivity. When the quartz is heated, it expands. So when it expands, then the charges realign and voltages are created. The principle we see in the later slides. So quartz resonance sensor, what are its advantages? One is, main thing the people are using is, one thing, they are having excellent accuracy and their cost is high. That is, if you see any quartz application, the even in points 90.25, anything that force or some other weight, it will be in terms of at least 2-digit accuracy the quartz applications will give. The output voltage will be for long-term stability. So if I replace quartz with capacitance, what happens is the capacitance is charged and the voltage varies, the output is obtained. But whenever we are removing the force or some other thing, the capacitor will discharge, and immediately if we place the weight in the weighing balance, as we saw in the earlier application, then what happens is this discharging voltage will change the voltage and it will reduce the output. So accordingly, the stability of the capacitor voltage is not, the output voltage is not there, but which is available with the quartz or piezoelectric crystal. The third one is low power consumption. Again, we saw that the capacitor consumes low power, but lower than the capacitance the quartz consumes. If the capacitance consumes 1 or 2 watts, the quartz crystal will definitely consume only in terms of milliwatts. That is it. That is the reason where we go for quartz application. Then the sensitivity of the temperature sensitivity is less. Even though we saw in the earlier cases, with respect, if we heat the quartz, it will expand, but it will not. It is not susceptible to outer temperature in the application, in which application it is used. This is the thing. Again, low susceptibility. Consider the LVDT case. Now, when we move the core, the output voltage is obtained. We know that. Suppose the LVDT will be manufactured with a shield or some other thing. But however, consider the LVDT is not having some shield. then, and if we are bringing our mobile phones, then definitely the output voltage will be changing. This is one thing. Also, I hope you might have seen, if we touch the CRO probe, the signal changes in CRO. So this is external interference. This sort of external interference is not there in quartz crystal. Next one is, we can transmit the output voltage even if it is less. We can transmit the output voltage for a longer distance since it is almost digital in nature. So as it is digital, we can interface with counter timer, counters, that is counter or timer, even timing device if it is needed, timer, and hence we can by suitable ADC or DAC or some other things, we can even interface with the digital computer system. Consider the quartz, that is the piezoelectric transducer here. It is the physical appearance of piezoelectric transducer is shown here. Now, the quartz crystal is placed in the electrode. So, whenever the quartz crystal is placed in the electrode, whenever we press, the voltage will be appearing across it. And this is electrode, this is contact between from this electrode to this electrode. If we have to connect the load according to our need, we have to connect a load according to our need. So whenever the quartz is pressed or piezoelectric crystal is pressed, a voltage is created, voltage is formed in between the two electrodes. Okay, so this is the physical presence. How now? Let us consider how that the voltage is created or is formed in the quartz crystal. That is, whenever we give mechanical stress or physical force or some pressure to the quartz crystal, then the quartz crystal has charges in it, inside it. So these charges are arranged in such a way that the net charge is 0. So inside the quartz crystal, the net charge will be under normal condition 0. When you press it, they will realign with each other. So one side positive charges will be higher and another side the charge amount will be lower. Automatically, this is the principle for a potential being created. Automatically, it creates a potential. For this, it consumes very much lesser power. This is so what happens is, I hope the physics people will be knowing this, the orientation of quartz crystal will change. So as the orientation change, the charge alignment of the quartz crystal will be changed. So this is the thing what is happening inside the quartz crystal. The next one is the quartz sensors, that is the piezoelectric sensors are manufactured in two ways. One is single beam force sensor, another one is double-ended tuning force sensor. Let us consider single beam force sensor. The name is given as single beam. So the quartz is placed in a beam, right? This is the beam and two fixtures are there. So they are non-functional fixtures. Kindly note that they are non-functional fixtures. Only they are supportingly holding it. So in between, in the middle, the piezoelectric quartz crystal is placed. So what happens is, whenever we press the beam or whenever we press the quartz, a voltage is being generated in the quartz. So or the input force we can press, or the input force may be in the also they have given by pressing the two fixtures. Two fixtures also, by varying the two fixtures also, the input force can be varied. So what happens automatically is the charges are realigned in the quartz crystal and the voltage is generated in the quartz crystal. So accordingly, we have to use, we can measure the force. Then the second thing is, this is the figure of single beam force sensor. The next one is double beam, that is double-ended tuning fork sensor. So double-ended tuning fork, two ends are there, they are functional, but one is used as mounting point only. We can move it here and there. The main thing is that here another end where the force is applied. They are giving us, we have given us applied load, but it is not it is not load actually. It is the input force. The input force we are applying here. So as the input force is applied, what happens? The charges are realigning themselves and the voltage is created. And this is the double-ended tuning fork sensor. The next one is the applications of quartz sensor, that is atmospheric, oceanic, seismic. But however, the main applications of the quartz sensor is the seismic nature, right? It is mainly seismic. Seismic refers to earthquake. Wherever earthquake is there, the device, earthquake sensing device is mainly using quartz sensor, since it is having a very low power consumption. Usually in our places, earthquake is not in our Indian country, earthquake is applying, that is occurring rarely. But however, if it occurs, then it should be measured accurately, for which quartz is used. So vibration sensor, it is a block diagram of the device. So we are using vibration sensor. That is, the vibration sensor is nothing but quartz. It is another sort of quartz. Temperature sensor is also used here, is just a quartz. So three quartz, we are different types. The quartz is also in rock, salt, or some other thing. They are having different materials. So by different materials, we are measuring seismic, and we are accordingly the voltage changes. And as the voltage changes, what happens is as the voltage changes, the voltage change will create accordingly. Wait a minute, please. Accordingly, the voltage change will create an output voltage, and it is amplified. So all the three things are measured by multiplexer, and it is converted into digital signal. So as it is converted into digital signal, the digital signal is stored in memory, and it is transmitted to the the required government agencies. So we have seen two sensors. As a conclusory remarks, let me summarize what we have discussed now. One is we have seen the capacitance sensor. Another one is we have seen inductive sensor. Capacitance sensor is used in mainly in displacement measurement, as well as we can use it. And inductive sensor, it is mainly used in displacement application and metal object detection application. And the capacitive sensor can be used in intruder alarm application, as well as intruder alarm application, as well as the third one, the quartz crystal. The quartz crystal is being used mainly in seismic application, as well as accurate measurement of force and pressure. So thank you very much for your watching. And participants, if you have any queries, you can post it in chat box. Participants, if you have queries, you can post it in chat box. Is retardation potential impacted by electric field? Yes, sir. The retardation potential will be definitely impacted by the electric field. Is there any other queries? That is, what to say, the electric field means what is the retardation potential? Actually, feedback link. Okay. Actually, so whenever electric field is there, whenever the potential, that is what to say, whenever electric field is there, the field changes means the potential will change. So even if it is what to say, the opposing potential, it will definitely change. This is the thing that is happening there. Thank you very much, sir. Ravindra, sir. That is Ravindra Dabde. Thank you, sir. Is there any queries, participants? Thank you very much, sir. Thank you, sir. So, ordinary one, but it is opposing in nature. That's why it will be definitely the potential will be affected by any other electric field. That's the thing. Is there any other queries, sir? Thank you, sir. Thank you. Thank you, madam. So shall we wind up the session?
Excuse me, Ayyappan sir.
Thank you.
Participants, kindly fill the feedback forms. The feedback link will be shared in the Google Meet as well as the YouTube live chat box. The attendance will be correlated from the feedback form submission. So kindly submit the feedback form, and the feedback form will be closed before today 10 p.m. So kindly fill before 10 p.m. today. There are two feedback forms. Each session there are separate each feedback forms. So kindly fill the two feedback forms before 10 p.m.
Palin sir,
Sir,
kindly paste the feedback form once again, sir.
Okay, sir. Already pasted, sir. Check once, sir.
Right now you paste it. Already, please once again paste it, sir. Participants, as per Mr. Paulin said, kindly fill the feedback form as early as possible. Before 10 p.m., you have to fill the feedback form. So kindly fill it. Please note on it.
Sir, feedback forms, will they be shared in WhatsApp?
No, sir, it won't be shared in WhatsApp, sir.
Where it will be accessible then?
And it's in the chat box, sir. Right now it
Okay.
is pasted in the chat box.
Okay, fine.
Also, it is available in YouTube live chat box, sir. You can also see the feedback link in the YouTube live chat box. It is pinned in the top of the chat box.
Participants, once again I pasted the feedback link. Kindly note down it. Okay, participants, thank you very much for your patience and listening. So we will meet again tomorrow at 6 p.m. Thank you very much. Let me wind up the meeting, sir. Thank you very much.
Sir,